provides a multiplication of the order of 2 raised to power n. Typically, there are different type of operations. So if we have different type of microprocessor operations, so we have different type of we have different types of microprocessor operations. Some are complex operations, some are very complex operations, very complex operations. So what is the example of complex operation? G, in terms of instructions that we have studied. G, very complex operation. Which of them are complex operations? जी बताएं. Anybody? Multiply and
So division.
division. These two operations are very complex operations. Divisions are complex operations. Why they are complex operations? Why they are complex operations? Why they are complex? Because they require frequent. Okay, if you think in terms of multiplications, how do you do perform multiplication? G, they require frequent addition and shifting. Am I right or not? So now let's assume if you want to multiply, let's assume if you want to multiply two numbers like A3, A2, A1 and A0 with B3, B2, B1 and B0. How do you calculate this? First you compute A0, B0. Am I right or not? Then A1, B0. Then what do you calculate? A2, B0 and then A3, B0. So this is the first step operations. You perform what if you look at this, what is like this. So if you look at this first step, so what is this operation? This one is bitwise what? Bitwise AND operation. Am I right or not?
Yes, sir. Bitwise and
We perform a bitwise AND operation of B0 with all the individual bits of A. Am I right or not? Hmm? Then we perform A1, A0, B1, A0, B1, A0, then A1, then A2, then A3. And actually what we do that we perform this operation with B1, B1, B1 and B1. This is the second operation. Then we perform the third operation. This one term is here, one term is here, one term is here and one term is here. And then we perform the last operation, this, and this and this. When we perform all of these operations, what do we do now? Ji बताएं. Is the first term bit, the second bit, the third bit, fourth bit, fifth bit, sixth bit, 7 bit, and how many bits are total there? And can anybody tell how many bits should be there?
8.
Why 8 bits? Why 8 bits? We already studied that if we multiply to n bit numbers, the result will be how many bits? बेटा आवाज बिल्कुल नहीं आ रही आप लोगों की, आप लोग बिल्कुल कंट्रीब्यूट नहीं कर रहे हैं. So we already studied that if we multiply to n bit numbers, the result will be am I right or not? So in this particular example, how many bits we have multiplied?
4 bits at 8.
We have multiplied 4-bit numbers. That's the reason that the result is 8 bits. The result is 8 bit. Okay, now if we classify the instruction of microprocessor, so there are simple instructions. So simple instructions are like logical shift left, logical shift right, add. So these are simple operations, and complex operations. Like are
Excuse me, sir.
जी बताइए बेटा
4 बिट नंबर हम मल्टीप्लाई करें तो रिजल्ट 16 बिट नहीं
हाँ? क्लास हो रही मेरी
सर रिजल्ट 2 पावर n बिट है ना तो 16 बिट
Oh. So we have already simple instructions and then complex instructions. Okay? Complex operation. जी बताएं आप कुछ पूछना चाह रहे थे बेटा
सर आपने ऊपर लिखा है ना ये 4 बिट के हमने मल्टीप्लाई करा है ना दो आपस में
हम्म
सर रिजल्ट 16 बिट आना चाहिए
Oh.
फिर 2
Why
की
it is
पावर n
no 2 raised to power n नहीं 2 multiplied by n. It is not 2 raised to power n.
ओके सर
n bits. And I have taught you in the earlier class that if we multiply to 16-bit number, the result will be 32-bit. If we multiply to 32-bit number, the result will be 64 bits. And if you can also
Yes, sir.
look at the result, that if we compute all these results, so this will maximum reach. And I also give you an example. For a 4-bit number, the maximum value is 15. Remember or not? Did you remember this or not?
Yes, sir.
And if you multiply 15 by 15, the result will be 225. And to represent 225, we need at least 8 bits. ठीक है बेटा?
Yes, sir.
Okay, so actually if we do this, like we have two types of instructions, simple instruction and complex instruction. So the simple instruction typically take 1 to 2 cycles, 1 to 2 cycles, and the complex operation like the divide and multiply instruction, they take more cycles, they took more, it's 15 to 30 cycles to compute. So which one is more expensive in terms of latency? So multiply and divide are more expensive in terms of what? In terms of latency. Okay, so these multiply and divide instruction are more expensive in terms of latency. Now if you look at the shift operation, so now we studied logical shift left. Logical shift left also provides the capability to multiply, but it only provides the capability to multiply by order of what? By order of what? Hmm? So this is fast or slow? This is fast or slow? Logical left shift left is fast or slow? Why it is fast? आवाज नहीं आ रही बेटा आप लोगों की.
सर फास्ट क्योंकि इसकी साइकिल्स कम है 1 to 2
Yes,
साइकिल्स
fast because it requires less number of cycles to compute. But that's the point, that if you say that if we have this instruction multiply R4 with 4, okay, this instruction is equivalent to shift left R4. Am I right or not? So if you look at the left instruction, how many cycles it takes? More cycles? And it takes less number of cycles. So which one is efficient? The left one or the right one?
राइट वन सर
Less one is less efficient. And on the right one?
The left more efficient.
more efficient. But that's the problem. The problem is that if you want to multiply, but if you, it's only used for integer multiplication. But if you want to multiply by, now let's assume if you want to multiply by 23, then can we do this with logical shift left instruction? Can we do this? जी बताएं बेटा. आवाज नहीं आ रही आप लोगों की. फजाना बतूल, फाइक अशरफ.
Yes, sir.
हाँ जी. Can we do this with logical shift left instruction?
Sir,
If you
no.
want to, but we can also do this using a combination. So can we write like this? How we can divide this? So let's assume that we have an operand 23y. So can we write it like this? 16y plus 4y plus 2y plus. Can we write like this or not?
Yes, sir.
So 16 plus 4 is equal to 20, plus 2 is equal to 22, plus 1 is equal to 23. So so what we can do? Let's assume can we do it like this? Let's assume, so if we have some register R3, so let's assume we have a register R2, and we multiply this with 23. So can we do it like this, that we can store this? So we take some other registers, we assume some other registers, okay. And let's assume we don't have any multiply instructions, so let's assume we have R1, let's assume we have R3, now let's assume we have 4, or now let's assume we have R5, so we have different instructions, different registers, and we perform the operation like this. So if we write the assembly code for this, first we multiply it with 16. So can we do it like this? Logical shift left, R1, R2, hash 4. What will be the contents of R1 now? G. What will be the content of R1 after the execution of this instruction?
सर लेफ्ट पे 4 zeros आ जाएंगे.
4 zeros आ जाएंगे, लेकिन I'm talking in terms of multiplication. Because logical shift left. So if you look at this instruction, logical shift left, it's provide multiplication of what? Multiplication of 2 to the power n. So 2 to the power n. What is 2 to the power n? Multiplication of 2 to the power 4, because now it's a 4. So it is multiplication by 16. So what will be the value of R1? What will be the value of R1? बेटा आप लोग सोए हुए हैं. What will be the value of R1? It's so simple.
2 raised to power 0.
Why 2 to the power 0? Why it will be 2 to the power 0?
अगर 1 के लिए करना है तो 1y के लिए.
बेटा I am shifting by 4
16 ही हो
places.
जाएगी क्योंकि वो उसमें शिफ्ट हो जाएगा.
16 what?
16 zeros आ जाएंगे.
Why 16 zeros? What is this?
So
What is
zeros.
this? Is source.
सर R2 को 4 times shift किया तो वो 16 हो गया.
16 what? And this one is destination. Okay, so destination should mean that the contents of R1 the contents of R1 will be equal to the contents of R2 left shift. This is the sign for left shift by 4. So it means 4 zeros will be inserted. So what will be the contents of R1? अब बता दे बेटा. Shift left. G. SL stand for shift left. Shift. G. What will be the contents of R1? अब बता दे.
16 ही होंगे.
16 what? 16 what?
16 will be multiplied by R2.
R2.
Very good. 16 R2. यही तो मैं आपसे पूछना चाह रहा हूँ ना. 16 R2. So the first instruction is LSL R1 R2. So okay, now we have another instruction. देखिए बेटा, अगर आप लोग ये तैयारी नहीं कर रहे हैं तो मैं इसी तरह के क्वेश्चन दूंगा. Now it can be a question like, let's assume if we want to multiply R2 with 23, you will not use multiply instruction. You can only use logical shift left instruction. Write an assembly language code for this. So how you can write this code in your OHT or on midterm or exam? I will ask these kind of questions. Assembly के questions होंगे, सारे assembly के questions होंगे. अब मर्जी है आप बेटा करें या ना करें. ठीक है? जी. Now let's assume if we then write another instruction. जी. Next instruction. If we write this instruction, LSL R3. Now we want to store the data in R3, and we want to perform the other operation. Now it is 16 R2. We want to multiply it with 4. So okay, the 4 पे करेगा तो how many shift we need to perform? जी बताएं बेटा. If we want to multiply R1 with 4, how many shift we need to perform?
So 2.
2. Very good. So we want to perform a shift of 2. So okay, now what will be the value? What will be the value of R3 after the execution of this instruction? What will be the value of R3?
2R1.
What? No. It is. So then R3.
20 R2.
Oh, why 20 R2 beta? R3 will be equal to R1, contents of R1 multiplied by 2 raised to power 2. And what is 2 raised to power 2?
4.
R1 multiplied by 4. यहाँ पे आप ऊपर देख लें. So it means that R1 in this particular case we are doing this with R2. Sorry, I have to change this with R2. Eraser and okay. Now it is R2. So what will be the value of R3 now?
So 64.
No.
Sir R2 के साथ जो previous value वो लेनी है.
What will be the value of R3? R2 is now the source.
Sir 4R2.
4R2. Okay. Now we have performed 2 operations. The first operation is highlighted here. The second operation is 4y. Okay. What should be now the third instruction? ये बताएं बेटा. What should not be the third instruction?
LSL 1.
What?
LSL1. LSL
Very good.
R3 R2
LSL.
hash 1.
LSL. No, not R3, because we have used R3. R3 has now contents of R2. We want to store this value in some temporary register R4.
R4 sir.
R4, very good. Then
R4
R2 same.
R2.
R2
Hash 1.
hash 1.
Yeah.
Okay, now
Hash 1.
if you look at this instruction, so it means that now after the execution of this instruction, so what will be the contents of R4? So the contents of R4 will be equal to the contents of R2 multiplied by 2 to the power what? 1. Why 2 to the power 1?
2 के साथ multiply करना.
So what will be the contents of R4 now?
2R2.
2R2. Okay, now 2R2. Okay, now we can. Okay, now we want to. What's our objective? Our objective is to store. Our objective is to store all the values in the register R5. Okay, so our objective is to store all the values in the register R5. Okay, so now what we have to do? What we have to do? G, what we can do now? We can use add instruction or not? Am I right or not? Add
Y रहता है.
add R5. So R5 is now the destination. Okay, so now we can add R5, R1, and R3. What will be the contents of R5 after execution of this instruction? What will be the contents of R5?
20
16
22
R2
R2.
plus 4R2.
22
What will
R2.
be the
16 R2
contents?
plus 4R2.
So 20 R2.
Yes, sir.
Okay, now
22
actually,
sir.
why? Because we are adding the contents of R1 and R3.
Okay,
R1
sir.
R1 has 16 R2 and R3 has 4 R2.
Okay, sir.
Okay, now we need another instruction. Okay, so now we need another instruction. Add R5. Now the previous contents of R5. The previous contents of R5 is 20 R2. Now we want to add 2y. 2y. Where is 2y? R4. So at this point, what is the contents of R5?
22 sir.
20 R2.
4.
And what is the contents of R4?
2 R2.
2 R2. So now what will be the new contents?
22 R2.
So this will be overwritten and the new value will be 22 R2. But now we want to have a value of 23 R3. So how we can do this? We need another. We need another instruction. G, बताएं बेटा. What instruction we need? Add R5. G. Add R5 and R5 with R2. So now what will be the new contents? What's the value of R2 at this point of time? (22 R2) and plus R2. What will be the new value of R5 now?
23 R2.
23 R2. So now the new value will be, this value will be overwritten, and now the new value will be 23 R2. Okay, so how many instructions? Okay, now this is a question. How many instructions are required to perform, to multiply R2 with 23? How many instructions we used?
6 sir.
Instructions we used? 6. What was the first instruction? This one. So this is the first instruction. Actually, we use 6 instructions. First instruction. Now this one is the second instruction. Now this one is a so we required a 4 to 1, and then we perform the addition, add, and add. So how many instructions we required? So 6 instructions. 6 instructions are required to multiply R2 with a value of what? With a value
23.
of 23. Okay. Okay, now if let's assume our architecture has one multiply instruction. Let's assume our architecture has one multiply instruction. So we can do this all with, we can all do this with how many instructions? Multiply 5. Am I right or not? Or 2 hash 23. So okay, now if you take, so now this multiply instruction take, let's assume 30 cycles. 30 cycles. And let's assume this shift take 2 cycles. So how many cycles are required to perform the above operation? 2, 2, 2, 2, 2, and 2. How many cycles are required to perform the above operation?
12.
12 cycles. Which one is faster? The first approach is faster or second approach is faster?
Sir, first faster.
Okay, now if you say first approach is faster, the second approach is slower. So the first approach required how many cycles?
12.
12 cycles. The second approach required how many cycles?
30.
Oh, okay, now I want to ask another question. What is the disadvantage of the first approach? Okay, the first approach is an advantage in terms of latency. So the first approach, in terms of latency. But what is the disadvantage of? What is the disadvantage? Can you let?
Sir, complex. More instructions.
Very good. What is the disadvantage of the first approach? Very good. For instruction. So it means more instructions are required. So how many instructions are required? 6 instructions are required. 6 instructions are required instead of how many instructions? Single instruction required for approach 2. Okay, now if we say that 6 instructions are required to perform the same operation, while in the second approach we require a single instruction. So which one will require more memory? Because instructions are stored in memory. Am I right or not? जी बेटा, any question? आवाज आ रही या नहीं आ रही?
आ रही है सर.
So more memory will be required in the first approach or the second approach?
First approach, sir.
Actually, I may ask similar kind of questions in your OHT and final year exam. that I will give you a scenario that, okay, for this scenario, solve this problem using multiply instruction, or solve this problem using logical combination of logical shift left or logical shift right, and then you can perform a comparative analysis of two different approaches. I will give a scenario. I may ask a question like this, like you want to multiply, if let's assume that the job is to multiply an operand with a value of any concrete number. It may be 23, it may be 35, or it may be any value. It may be 47, it may be any value, and solve this problem using logical shift left or use a multiply instruction. And you have to write the complete assembly language program to achieve that objective, and then you can perform a comparative analysis of this of these two approaches, that if we want to solve a problem. So in this particular example, we wanted to multiply an operand with a value of 23. If we use a multiply instruction, we can use a simple multiply instruction. But multiply instruction has a disadvantage that it takes more cycles. Like it takes, we can solve the same problem using a combination of shift instruction and add instruction. So in this particular example, if in this particular example 6 instructions are required. Now let's assume if we want to multiply an operand like 12 12x. How can we divide this? G, how can we divide this in multiples of 2?
8 and 4.
Very good. So 8m plus 4m.
4.
For the first
4m.
one, okay, for the first one and for the second one, how many shifts are required? Shift by what?
3 and 2.
Shift by 3 and 2. Very good. So you can partition the same problem into different sub problem or sub instruction, and when you divide this into sub problem or sub, okay, so it means that how many shifts we require? We require 2 shifts, one for 8, one for 2, and we also required one addition. We require one addition. Am I right or not? It means 2 shifts. It required 2 shifts. And how many additions?
2 addition.
One addition. So how many cycles will be required to multiply by 12? How many cycles will be required?
6 cycles. 6 cycles.
6 cycles. So 6 cycles will be required. 6 cycles will be required, assuming that the add and shift operation requires 2 cycles. Am I right or not? Okay, so now we proceed further, and now we will study rotate instructions. So we have 2 types of instruction. One is rotate left and one is rotate right. So the rotate left will shift the bits of the MSB on the LSB side. Okay, so now just take an example. We will take a simple example. So now let's assume that we have an instruction rotate left R5 6. So now let's assume we have an R5 here. R5 here, and let's assume the contents of R5 is P15, P13, P12, P11, P10, 9, up to P3, P2, P1, and P0. So what will be the value of R5 after execution of this instruction? जी बताएं बेटा. What will be the value of R5? Can anybody give me a clue? This one is an old R5. And now we have new R5. So what will be the new contents of R5? G beta beta. So now we are rotating R5 by 6 positions. So it means that the most significant bits. How many more? 1, 2, 3, 4, 5, 6. This will be moved on the LSB side. Okay. So initially, which value will be moved on the LSB side? Any clue? बताए ना? G15 will move on the LSB side. Then B15 will be moved, and then before moving this B15, this B15 will be shifted on the left. Which value will be moved next? जी बताएं बेटा. Abdullah. Abdullah.
Yes.
Which value will be moved next? Abdullah, आपकी आवाज नहीं आ रही.
सर
Ahmed Awais. Ahmed Awais.
Yes, sir.
आपकी आवाज नहीं आ रही. बताएं बेटा.
Yes, sir. Yes, sir. Sir,
हाँ,
आवाज आ रही
B14 से
है?
आगे जाएगा.
Sir, B4. Sir,
B14,
क्या
B13,
क्या?
B12.
B13, then B12,
B12,
B13,
then
B12, B11.
B11, and then
4 तक ऐसे ही जाएगा.
B10. And what will be the MSB now?
B3 हो जाएगी.
Now, what will be the MSB? No. What will be the MSB? The MSB will be
Sir,
B9.
B0.
B9,
Sir, B9 कैसे?
B8, B7, B6, B5, B4, B... बेटा नहीं समझ आई बेटा, या नहीं आई अभी?
आगे है सर.
सर ये कमांड हम कर क्या रहे हैं? सर रोल कमांड से.
रोल नहीं, रोटेट लेफ्ट.
Rotate
Rotate left.
left.
So we are rotating. Okay, actually, what will happen? First, okay, we are rotating by 6 places. And the values that are on the MSB side will be moved to the LSB side. नहीं समझे बेटा? 6 MSB.
सर होंगे क्या? मतलब समझ नहीं आई.
क्या समझ नहीं आई? समझ आई बेटा, बताएं बेटा.
मतलब सर किस ऑर्डर में मूव होंगी? मतलब उस जगह, मतलब पीछे शिफ्ट.
So,
Like
okay, if it moves, so let's assume. So, okay, what was the size of R5? ये बताएं. पहले ये बताएं. What is the size of R5 in this particular example?
sir, ये 16.
These are 16 bits. So first, the MSP will be moved. B15 will be moved. Then B14 is moved. Then B13 is moved. Then B12 is moved. Then B11 is moved, and then B10 is moved. अब समझ आई बेटा या नहीं आई?
सर ये मतलब इसका मतलब मोस्ट सिग्निफिकेंट 6 पहले बिट्स को
Yes.
बिल्कुल एंड पे ले जाएं.
End पे ले जाए. Yes. Because why 6? Why 6? Because we have written a 6 here. And if we write it 8 or 2, then if we say rotate left, okay, So now let's assume we have another instruction. Now let's assume we have another instruction. Rotate left R5 with the value of 2. So what will be the content? What will be the new R5?
सर मोस्ट सिग्निफिकेंट B13 होगा और लीस्ट सिग्निफिकेंट B14 हो जाएगा.
Very good. So that's the point. So in this case, the new value of R5 will be B15 and then 14. समझ आई बेटा या नहीं आई बेटा?
आ गया.
ठीक है. अच्छा, now let's assume, can you give me assume a scenario, if we say now I have a problem for you and then you have to solve this problem. If we say, so I can also give you a problem in the, say, let's assume that we have a register R2. Let's assume we have a register R2 and the contents of this register is, the content of this register is in terms of hexadecimal. So let's assume in hexadecimal, the contents is 365A. So now let's assume the contents of this R2 is 365A. So what is the size of R2 in bits? What is the size of R2? बेटा बताएं.
16 bits.
16 bits. Very good. So the size of R2 is 16 bits. What is the most significant? जी बेटे बताएं.
Sir,
Any question, please? 3 क्या?
36.
Okay. So what is the most significant byte in this particular example? This is the most significant byte, not bit, byte. Byte. Okay. What is the size of bytes in bits? 8 bits.
Sir, 8 bits.
Okay. What is the least significant byte in this particular example?
Sir, 5A.
So this is least significant byte. And now we have a problem and we want to solve this problem. So write an assembly language program, write an assembly language instruction to swap the byte. Means that the most significant, the the most significant byte, will become least significant, and the least significant byte will become most. It means that now the new contents of R2 should be, so now let's assume that the new contents of R2, so the new R2, what should be the new R2 for this problem set? बताएं बेटा, we want to swap them. Abdullah?
जी sir.
If we want to swap the byte positions, what will be the new contents now of R2?
5836.
5836, very good. So the new contents will be 5836. So what should be the assembly instruction to perform this operation? जी बताएं. Now this
Sir,
is
ROL R2 hash 1.
ROL, very good. R2 what? Hash what?
Hash #1.
Why #1? #1 will
हैश
move only one
हैश
bit.
8 होगा
#8.
सर क्योंकि हम 1 बाइट को मूव कर रहे हैं.
No, 1 byte को. Actually,
#8
#8. Why #8?
क्योंकि
Because
8 बिट के दो सेपरेट है ना बीच में
because we
डिवाइड है
have to
because
move
a
8 bits.
byte consists of
8 bits.
8 बिट्स
bits. We are not moving a single bit. We are not rotating a single bit. Instead, we are rotating 8 bits. When we say that we are rotating 8 bit, so this implies that we are rotating 1 byte. बेटा समझ आई या नहीं समझ आई बात? चंदुला समझ आई या नहीं आया अभी तक?
आगे सर आगे.
Okay. So similarly, rotate right. So we have also have ROR, rotate right R3 with. Now let's assume that the contents. Let's assume a scenario that the contents of R3. The contents of R3. Let's assume the contents of R3 is this. So what should be the new contents? Now we are rotating on the right. So what will be the new contents of R3? जी बेटा बताएं. It is not rotate left now. It is now rotate right. Can anybody have a clue?
सर लीस्ट सिग्निफिकेंट को मोस्ट पे ले जाएंगे
Very
बिट्स
good.
को.
So the new contents will be P15, the least significant 3 bits. So the least significant 3 bits will be moved to the MSB side. So what will be the new contents, beta?
B2 B1 B0 B15 B14
2, B1, B0, and B15, and so forth, so on. And then in the last, P3. ठीक है बेटा, समझ आ गई बात आप लोगों को? Any question? Any question relevant to logical shift left, logical shift right, rotate left, and rotate right? So summarizing our lecture regarding rotate instruction and logical shift left instruction. So the logical shift left instruction provides the capability to shift by the power of 2 raised to power n. Okay. And logical shift right instruction provides a division by 2 raised to power n. Okay. And what about rotate left? Rotate left and rotate right can be used to swap the least significant bits to the most significant positions or to rotate the most significant position to the less significant position. ठीक है बेटा? Any question? ठीक है.